arc length and sector area. Okay, we already did this. The arc length is like the length of the crust of your pizza. The sector area is like the area of your slice of pizza, right? So we already did this before, but when we did it, we only did it with degrees, right? So we need some new formulas that can be used in case they give us radians instead of degrees. So here are a couple formulas, and I'm going to show you how they can simplify if you want to use the simplified formula. But remember, I will let you guys use your note card on your test. On the exam that you guys have to take on the 18th of December, there are no note cards. So formulas like this have to be memorized. So I want to show you how close, oh gosh, I did this totally wrong. Losing my mind. Okay, let me just fix this right here real quick. Okay, that 360 is wrong because that would be degrees. I didn't even fix my notes on this. Let me fix it really quickly. Let's get rid of this. Okay. Let me put in the correct thing here. Our area is going to equal theta over 2 pi times pi r squared. Okay, so basically on yours, the only thing that you've got to fix there is that instead of 3, you need to mark out that 360 that I put there on accident and make that 2 pi. If you still have your note cards, which I hope you do, for the stuff that we were doing with circles, the only difference in this formula and the arc length formula that we had is that instead of using 360, we're now using 2 pi right here. Okay, and same thing for our sector area. Mark out that 360 that I had there because that was incorrect. And then we're using 2 pi. So the formula is the same, except for instead of 360, we're using 2 pi because our whole circle is going to be 2 pi. Now, these formulas will simplify. So let me show you something here. Okay, so there is an easier version of these formulas. But once again, we are going to have these memorized. So I would probably use these because they're easier to remember. So if I put this over 1 here, if I multiply straight across, that would be theta times 2 pi times the radius, and on the bottom I would have 2 pi. Right? What is going to happen? All this stuff is multiplied together. What's going to happen with the 2's? If I got one on top and bottom, they cancel out. What about the pi's? They also cancel out, right? So that means I can also write this formula where my arc length equals just theta times r, which is a lot easier to use, but remember, you're going to have to remember this on your exam as well. So I would include both of these formulas on my note card. So if you want to add those to your note card, this is the long formula, right, that looks like the one we were using for degrees. This is the short formula that you can use. So this is just a long version, and this is your short version. Okay. The sector area formula also simplifies a little bit, not as much as the arc length formula. The arc length is a little bit easier. So if we look at this, if we do the same thing, if we put this over 1, that would be theta times pi times r squared. And on the bottom we would have 2 pi. Do I have anything that can cancel there? Just the pi, right? So for this one, my area formula can be theta r squared divided by 2, or if you would rather, you can write it this way. The area is 1/2 times theta times the radius squared. And this one right here sometimes is a little easier to use. Multiplying something by 1/2 and dividing it by 2 are equivalent, so you can write it either way. So I would have both of these on my note card as well. You got the long version of sector area and the short version. Short version is going to be easier to use. Long version is easier to memorize for these. Okay, questions so far?
What is the O with the theta?
That is your angle. So we can write that. The theta is your angle.
Wait, so like whatever number, are we like putting a number, putting a number into it?
Yes, it's a variable where you're plugging a number for it. Yeah.
How is the longer version? It's like an X, but not an X.
It is, the longer version is exactly the same as the one we use for degrees. The only difference is that the bottom right there is 2 pi instead of 360. And this is circumference, this is area right here. So it's just a fraction of your area. This is a fraction of your circumference. So the degree formulas do not have a shortcut. There is no like simplified version of those. So if you already know degree, you don't have to learn a new one for the radians.
And the short and the long, there's no difference.
You can use either one. Yeah, I'll show you how they both give you the same answer. The short one is going to be easier to use, but it's just if you already know your degree formula, then all you got to do is change 360 to 2 pi, and you know your radians. All right, let's put this into practice here. Okay, so these ask for arc length. Arc length is the crust. It's the edge. Okay? The formula, I can use either the long version, which is theta, which is my angle, over 2 pi times 2 pi radius, or the short version, which is easier to use. That's just theta times the radius. So this right here, 3 pi over 4, that's my angle. That is theta, right? My radius is 7. So it is definitely easier to use theta, which is 3 pi over 4, times the radius, which is 7. We're going to put that over 1. These are not going to be decimal answers. They're not going to give you decimal answers on these. So you need to multiply these by hand. To multiply fractions, you just multiply straight across. So you'll get 21 pi over 4. Okay. The angle is the one with the pi. Yes. Yeah, this is the short one. Yeah, this is your angle. That's your theta. And the other one right here is your radius. That 7 is your radius. Yeah. It is definitely easier to use that. I am going to show you how the other one gives you the same answer, but if it confuses you, don't let that like mess you up there. So if I did this with the long one, I'd have 3 pi over 4 over 2 pi. You can see why this is a little more confusing. Times 2 pi times 7. But really what happens here is really the same thing, because like this is over 1. And so that 2 pi right there cancels with the 2 pi right there. And then you just have to do 3 pi over 4 times 7, which is just what we just did, 21 pi over 4. So it's easier to use the one that already has the 2 pi's canceled out, but if you use the longer formula, the same thing's going to happen every time. Those 2 pi's will cancel. Okay, so if we have to do number 2, then we could just do the angle, which is 7 pi over 12, times our radius, which is 9. We'll put 9 over 1 since it's not a fraction. I'm going to multiply across, so 7 times 9 is 63 pi over 12. I didn't check on this last one to see if that would reduce. It doesn't. I'm pretty sure this one's going to reduce. Yep, we can divide both of those by 3. So, or you can do it in your calculator if you want. You'll just do, don't put the pi in, 63 divided by 12. Math, enter, 21. Oh, gosh, the same answer. Huh, I did not make these notes. These are Miss Martin's notes. They're not, that's a coincidence that those are the same answers. So that is 21 pi over 4. And you do want to reduce these if you can. So that 63 over 12 is what you're reducing. Yeah, you want to simplify if you can. But I don't want you to type it in and give me a decimal.
Okay.
Yeah, I want the pi to still be in the answer for these.
So it's basically like kind of what we've been doing?
It's what we were doing. We did this earlier with degrees. We're just doing circles now. Or, well, we're still doing circles, but we're just doing radians now.
Okay.
Yeah. Okay. For number 3, William, what would I have to do for number 3? Okay. That is going to give me 50 pi over 4. Will that reduce? Yeah. What will I get? 25 pi over 2. Right there. Beautiful. Everybody okay here? Okay, let's look at area real quick, and then we'll be done. So my area formula, the long version for area is theta over 2 pi times pi r squared, right? Or the short version is going to be, I like the 1/2 theta r squared the best instead of the theta r squared over 2, but you can use either one. A lot of times if you do. Since theta is often a fraction, if you do divide it by 2, you end up having to like flip and multiply there. All right, so definitely it is easier to use that second formula. You're going to have 1/2 times your angle, which is 7 pi over 6, times your radius squared, so 8 squared. And I'm going to put this over 1 right here so that I got all fractions, right? And actually, probably before I multiply stuff together, I'm going to do 1/2 times 7 pi over 6, and I'm going to go ahead and square that 8, so I'll have 64 over 1. And so when I do this, I'm just going to multiply straight across there. Don't include the pi when you put it in your calculator. We're going to do 7 times 64. It's probably going to give us a pretty big number. We got 448. So 448 pi over 12. I feel pretty confident that's probably going to reduce. So I'm going to do 448 divided by 12, and I'm going to hit math, enter, and that's 112 over 3. So I'll get 112 pi over 3. A lot of your answers for these are going to be fairly big fractions. That is okay. I'm not going to do 5 because it has the same angle. So it's pretty much the same problem except we changed that 8 to a 10 right there. So let's just skip down here and do 6. For 6, I would do 1/2 times my angle, which is 5 pi over 4, times my radius squared, which is 12 squared, and I'm going to put that over 1. So again, I like to go ahead and do that square first so it doesn't get like messed up. So 1/2 times 5 pi over 4 times 144 over 1. And so if I multiply that top, I'm doing 144 times 5. And I get 720. 720 pi over 8. And then I want to reduce that. So 720 over 8. Math. Enter, enter. I get just 90. Just 90. So there is no denominator on that. It's just going to be 90 pi. Okay? All right, questions? All right, so we have